For thousands of years, humanity has looked at the sky and wondered about the universe. The night sky has always inspired human civilization. Early humans observed stars, planets, and celestial movements. Ancient astronomers tried to understand the mysteries of space using primitive tools and observations. Among all the planets visible from Earth, Mars has remained one of the most fascinating worlds. Mars is often called a red planet because of its iron-rich surface soil that creates a reddish appearance. When people look at Mars through telescopes, they see deserts, mountains, and large canyons. Scientists believe Mars was not always a desert planet. Billions of years ago, Mars may have had a thicker atmosphere and liquid water on its surface. Geological research conducted by space missions has discovered minerals that form only in water environments. This means ancient Mars might have supported microbial life. However, something changed in Mars history. Scientists believe Mars lost most of its atmosphere due to solar wind activity. Mars does not have a strong magnetic field like Earth. Earth's magnetic field protects life by blocking harmful radiation from space. Mars lost this protection billions of years ago. As a result, solar radiation slowly removed atmospheric gases from Mars. Today, Mars has an extremely thin atmosphere. Atmospheric pressure on Mars is less than 1% of Earth's pressure. This means liquid water cannot remain stable on the Martian surface. Temperatures on Mars are extremely cold. During winter nights, temperatures can drop below minus 100 degrees Celsius. Dust storms sometimes cover large areas of the planet. Some storms can even spread across the entire planet. Despite these harsh conditions, Mars remains humanity's next exploration target. Modern Mars exploration began with robotic spacecraft missions. In 1965, NASA successfully sent the first close images of Mars using Mariner missions. These images showed a cratered surface and changed scientific expectations. Later missions continued exploring Mars in greater detail. Rovers and orbiters were developed to study Martian geology and atmosphere. The National Aeronautics and Space Administration, commonly known as NASA, is currently one of the most important organizations leading Mars research. NASA is following a careful long-term strategy for human Mars exploration. Instead of sending humans directly to Mars, NASA wants to establish permanent human presence on the Moon first. The Moon will act as a testing environment for deep space survival technology. Through the Artemis program, NASA plans to develop lunar infrastructure. Scientists want to learn how humans can live far from Earth for extended periods. NASA plans to use advanced launch systems, such as the Space Launch System rocket and the Orion spacecraft. Human Mars missions are expected to be extremely complex. Travel time to Mars may take 6 to 9 months, depending on planetary alignment. During this journey, astronauts will face radiation exposure. Cosmic radiation is dangerous because it can damage human cells and DNA. Microgravity during space travel can also weaken muscles and bones. Scientists are studying how the human body adapts to long-duration space travel. Communication delay is another major challenge. Because Mars is millions of kilometers away from Earth, radio signals can take several minutes to travel. This means astronauts cannot depend on instant communication with mission control. They must be trained to operate independently during emergencies. Private space companies are also contributing to Mars exploration. One of the most ambitious companies is SpaceX. SpaceX was founded by Elon Musk with a vision of making humanity a multi-planetary civilization. Elon Musk believes that Earth may face future risks, such as natural disasters, asteroid impacts, or environmental changes. To ensure long-term human survival, humanity must expand beyond Earth. SpaceX is developing the Starship spacecraft. Starship is designed to be fully reusable. The rocket system may carry more than 100 passengers in future missions. One of the revolutionary ideas behind Mars missions is in situ resource utilization. This technology aims to produce fuel directly on Mars. Scientists are studying methods to extract carbon dioxide from Mars' atmosphere. By combining carbon dioxide with underground water ice, methane and oxygen fuel can be produced. If this technology succeeds, future Mars missions may not need to carry return fuel from Earth. SpaceX has suggested crewed Mars missions could begin in the early 2030s. However, Many scientific experts believe the first verified human Mars landing may happen closer to 2035 or later. China is also advancing rapidly in space technology. The China National Space Administration is investing in propulsion research. Chinese scientists are studying nuclear thermal propulsion systems. These propulsion technologies could reduce Mars travel time. China's human Mars mission timeline is estimated between 2033 and 2043. European space organizations are also contributing to Mars science. The European Space Agency collaborates with NASA on planetary research missions. International cooperation is becoming increasingly important. Mars missions require enormous financial investment and technological resources. Radiation protection is one of the biggest scientific challenges. Mars does not have a strong magnetic field. Astronauts traveling to Mars will be exposed to cosmic radiation for long durations. Psychological isolation is another serious challenge. Mars astronauts will live millions of kilometers away from Earth. Emergency rescue missions will be extremely difficult. Therefore, astronauts must be highly trained to operate autonomously. The financial cost of Mars missions is extremely high, depending on infrastructure development and mission complexity. Total costs may exceed hundreds of billions of dollars. Once humans reach Mars, the first missions will focus on survival and scientific research. Astronauts will live inside specially designed habitats. They will extract water ice from underground soil. They may grow plants inside controlled greenhouse environments. Scientists will search for chemical biosignatures. These biosignatures may provide evidence of ancient microbial life. By the 2040s, Mars may host small scientific research bases. Astronaut crews may rotate between Earth and Mars missions. By 2050, if technological development continues, hundreds of humans could live on Mars inside radiation-protected structures. However, colonizing Mars is far more difficult than visiting it. Terraforming Mars remains a theoretical concept. It may take centuries to transform Mars into an Earth-like world. Mars may never become a green planet in the near future. Instead, Mars may remain a scientific research frontier, a place where humanity studies deep space and survival technology. When the first human steps onto Mars, it will represent one of the greatest achievements in human civilization, not only for science, not only for technology, but for humanity itself. That moment will symbolize the beginning of a new era. Humanity may one day expand beyond Earth. Mars will no longer be just a red dot in the night sky. It will become part of our future story. The final question will remain: when will humans go to Mars? The answer is still being written in rocket laboratories, in scientific research centers, and in the dreams of explorers who believe humanity's destiny lies among the stars.